Using the results obtained in the last section, we can obtain the force of attraction between the two long parallel wires separated by distance d. Consider I1 and I2 be the currents passing through wire 1 and wire 2. D is the distance of separation between wire 1 and 2. B1 is the magnetic field produced at wire 2 due to the current I1 passing through wire 1. This can be calculated by using the formula B is equal to mu naught I upon 2 pi r, which we have studied in the last section. B1 is equal to mu naught I1 divided by 2 pi d. This is equation 1. The direction of B1 is into the plane of a paper by using the right hand rule shown here by cross sign. According to Lorentz force law, magnetic force F21 acts on the wire 2 carrying the current I2 due to magnetic field B1 produced by current I1 passing through the wire 1 can be calculated by using equation F is equal to ILB sine theta. This is represented by F21, that is the force acting on second wire carrying current I2 in magnetic field B1 produced due to the current I1 in wire 1 is equal to I2 multiplied by B1 into integration over dl. Substituting value of B1 from equation 1, I2 into mu naught I1 upon 2 pi d integration over dl can be written as L, that is the length of the section of wire. Therefore F21 is equal to mu naught I1 I2 into L divided by 2 pi d. This is equation number 2. Using right hand rule, the direction of the force F21 is directed towards the wire 1, that is, it will be attractive force. Similarly, F12 represent the force acting on wire 1 carrying the current I1 in the magnetic field B2 produced by current I2 flowing through the wire 2 is equal to mu naught I1 I2 into L divided by 2 pi d. This is equation number 3. According to right hand rule, the direction of F12 is directed towards the wire 2. Therefore F12 is equal and opposite to F21, that is F12 is equal to minus F21. Now the force of attraction per unit length of the wire is given by F divided by L is equal to mu naught I1 I2 divided by 2 pi d. This is equation number 4. This equation gives the force of attraction per unit length of the wire. Now if currents I1 and I2 are in opposite directions through the wire 1 and 2, there will be the force of repulsion, and this force of repulsion due to I1 and I2 in opposite direction is given by F upon L is equal to mu naught I1 I2 divided by 2 pi d. This is equation number 5. So from the above results we can summarize the parallel currents attracts and anti-parallel currents repel each other. From the equation 4 we can define the SI unit of the electrical current, that is ampere. We have force per unit length F upon L is equal to mu naught I1 I2 divided by 2 pi into d. Here the mu naught is equal to 4 pi into 10 raised to minus 7 Weber per meter. When d is equal to 1 meter, then for I1 is equal to I2 1 ampere. Substituting these values in above equation, we can write force per unit length is equal to 4 pi into 10 raised to minus 7 into 1 multiplied by 1 divided by 2 pi into 1. This will become the 2 into 10 raised to minus 7 Newton per meter. When the two conducting parallel wires separated by distance 1 meter placed in the vacuum, the constant current through these wires producing a force on each other of the magnitude 2 into 10 raised to minus 7 Newton per meter, then the current through each wire is equal to 1 ampere. Therefore, we can define 1 ampere. Consider two parallel conducting wires having the infinite length have separation of 1 meter are placed in vacuum. The constant current through these wires producing a force on each other of a magnitude 2 into 10 raised to minus 7 Newton per meter of their length is 1 ampere. Let us find magnetic field produced by the current in circular arc of wire. Figure shows the circular arc of wire AB. Radius of the arc is r. The current passing through the arc is I. Arc AB makes the angle theta at the center of circular arc. To find the magnetic field induction at point O due to the arc AB, first we have to find out the magnetic field produced at point O due to one current length element IDL along the length of arc AB. We will write notations using Biot-Savart law. Magnetic field produced at point O due to one current length element IDL is given by vector dB is equal to mu naught upon 4 pi I into vector dl cross vector r divided by r cube. This is equal to mu naught upon 4 pi I dl into r sin theta divided by r cube. This will become mu naught upon 4 pi I dl into sin theta divided by r square is equal to mu naught upon 4 pi I into dl sin 90 degree divided by r square, as here the angle between vector dl and vector r is 90 degree. Therefore, a theta is equal to 90. Therefore, vector dB is equal to mu naught upon 4 pi I into dl divided by r square, as the sin 90 is equal to 1. This is equation number 1. According to right hand rule, the direction of the magnetic field vector dB at point O is into the plane of paper, shown by here cross sign. Now total magnetic field at point O produced due to all current length elements along the length arc AB can be obtained by integrating equation 1. B is equal to integration over dB is equal to integration over, substituting the equation 1, mu naught upon 4 pi I into dl divided by r square, as the mu naught I divided by 4 pi r square is constant, taking outside of the integration is equal to mu naught upon 4 pi into I divided by r square, integration over dl. But integration over dl is equal to total length of the arc AB, and therefore mu naught upon 4 pi into I divided by r square multiplied by arc AB. Rearranging equation, mu naught upon 4 pi into I divided by r into bracket arc AB divided by r. Arc AB upon r is equal to angle theta, that is the angle subtended by arc AB at the center O. Therefore mu naught upon 4 pi into I upon r multiplied by angle theta. This equation gives the total magnetic field produced at a center O due to current passing through the circular arc AB. By using this relation, we can find out the magnetic field at the center of full circle of wire carrying the current I. Here, for the full circle, the angle subtended by circumference of circle at the center is theta is equal to 2 pi radian. Therefore, above equation 2 becomes B is equal to mu naught upon 4 pi into I divided by r into 2 pi. Here pi will get cancelled and 2 to the 4. This is equal to mu naught into I divided by twice r. This equation number 3. This equation gives the magnetic field at the center of full circle of wire carrying the current I.